Evaluate piecewise defined functions. Well, we already know what evaluate means. That means we can plug in a number and kind of just solve the problem and it outputs a number for us. Cool. All we're doing is just put the number in, figuring out what the answer is. That's evaluating. Piecewise defined functions look kind of like this. So find the function of 6 for this piecewise defined function. Now, what this means is you're going to be substituting the number 6 into both of these functions. But first, they have parameters set with them, limits. Kind of like when we were talking about domain and range, how we had a line segment with 2 closed circles or one with an open circle and one with a closed circle. That was a piecewise defined function, meaning that it terminated at 2 points. Right now we have limits set up on this to where if x is less than or equal to 4. Okay, well let's take a look at the information that was given and then do a little check before we start solving things. If we know that the function of 6 is what we're going to be using, that means we're substituting 6 in for our x value. This tells us that x has to be less than or equal to 4. 6 is not less than or equal to 4. That means 6 will not work for 7x plus 2. That is a function in itself. Now, if we wanted to take a look at the second one, x is greater than 4, 6 is greater than 4. That means we can use that value given, the function of 6, in for the x value for negative 3/4 times x plus 2. So really what's taking place is you're given parameters. The value of your domain is being manipulated. It's being put with walls around. It's being put in a box. And you have to find the values that fit in to these functions that you're being given. Once you find out this is within the parameters of the box, the information I'm given fits between these two walls, then you can start solving and find out what your range would be given those parameters. So all I did was what we've been doing in the previous sections. I verified if it fit in the range that was given. X is less than or equal to 4. No, it didn't, so I put an X there. 6 is greater than 4. Cool, so I substituted in for that particular function. Taking a look over at the second example, function of negative 7. Go through the same process. Anytime you have piecewise defined functions, there's going to be parameters. What you have to do is verify the information you're given fits within those parameters. If it doesn't, then you're not able to manipulate that domain using that input. So if x is less than or equal to negative 8, that means that negative 7 has to be less than or equal to negative 8. And a common error that comes up is negative 7 is less than negative 8. No, it's not. Negative 9 would be less than negative 8. Negative 8 would be equal to it, but negative 7 is definitely not less than negative 8. So that puts a big X on that function. It's not going to fit within the parameters that we were given. But if you take a look at the second one, right here, x is greater than negative 8. Negative 7 is greater than negative 8. It's closer to 0. It has a higher value. So that means we could take negative 7 and substitute it in for x minus 3. That's exactly what I did right here. And that was able to generate an output for the x value we were given. So just working within parameters that are given to us for x values. This is manipulating the domain, how far side to side the function is going to go. Here's an example we can go through together. So the function of 3. Okay, so what we need to do is we need to check the parameters. Is it going to work? So if x is less than 7, so 3, is 3 less than 7? Yes. Cool, this one's good to go. We can use that. Now let's check the second one. If we substitute 3 in, is 3 greater than or equal to 7? No. So that means this one's a no-go. What we're going to do is we're going to take the information, negative 8x plus 2, and we're going to substitute the x value in because it fits within the parameters that were given for that function. So negative 8 times 3 plus 2. Follow order of operations, plus 2, negative 22. So that generated an output of negative 22 that fits within the parameters of the domain limits that we were given.